Hello students, we're going to learn 3.7 slopes of parallel and perpendicular lines. Recall that this symbol means parallel and this symbol means perpendicular as discussed earlier in this class. If line 1 is parallel to line 2, then the slope of 1 equals the slope of line 2. So for example, if the slope of line 1 is 2, then the slope of line 2 is 2. If the slope of line 1 is negative 1/2, then the slope of line 2 is negative 1/2. If line 1 is perpendicular to line 2, then slope 1 is equal to the opposite reciprocal of slope 2. Again, this is opposite reciprocal slopes. So if we have opposite reciprocal slopes, then the lines are perpendicular. An example of that, if the slope of line 1 is negative 2/3, then we know the slope of line 2 is the opposite. So opposite of a negative is a positive. The reciprocal of 2/3 is 3/2. If the slope of line 1 is 4, then the slope of line 2 is opposite of positive is negative. The reciprocal of 4 is 1/4. So make sure you understand these relationships. Alright, so let's take a look at some graphs. They want to determine whether the lines are parallel, perpendicular, or neither. So let's take a look at this first part here. So to find the slope between 2 points, we can look at the graph. So the slope from this point to this point, it's rise 1, right 1. So the slope of this is going to be, let me put it right here, M2 is 1/1, which is 1. The slope of line 1, 1, 2, 3, 1, 2, 3. So slope of line 1 is 3/3, which is 1. So since the slope of line 2 is equal to the slope of line 1, therefore L2 is parallel to L1. So again, if the slopes are equal, then the lines are parallel. And again, all I did was find the slope by either going up or down, right or left. Make sure that you notice when the lines are increasing, the slopes are positive. Later on, you're going to need that concept in calculus. Alright, so let's take a look at this. Let's look at line 1. So line 1, there's a point here and a point here. I'm going to move up 1, 2, 1, 2, 3, 4. So the slope of line 1, again, 1, 2, 1, 2, 3, 4. 2/4, which is 1/2. And if we look at line 1, is line 1 increasing or decreasing? Line 1 is decreasing. So if line 1 is decreasing, the slope is going to be negative. Let's take a look at line 2. So the slope is your rise over run. So from this point to this point, we have 1, 2, 3, 4, 1, 2. And line 2, moving left to right, it's increasing. So if the line is increasing, that means the slope is positive. Well, we have opposite reciprocal slopes. So since M1 is the opposite reciprocal of M2, our conclusion is L1 is perpendicular to line 2. Alright, so let's take a look at this last example on this page. Here is line 1. Line 1 is decreasing, so I know it's going to be negative. So the slope of line 1, it's going to be negative. So let's 1, 2, 3, 1, 2. Slope 2, that's negative as well. So we're going to go up 1, 2, 3, 4, right, left 2, 1, 2. Well, the slopes are not equal to each other, and they're not opposite reciprocal. They're both negative, and they're not reciprocal. So the conclusion is this is going to be neither. So since the slopes are not equal, and the slopes are not opposite reciprocal, line 1 is not parallel and not perpendicular to line 2. Alright, the next thing we're going to do is we're going to check algebraically if the lines are parallel, perpendicular, or neither. So let's take a look at part A. In order to find the slopes, make sure the equation is in slope-intercept form. This is in slope-intercept form because y is by itself. So the slope of this line is -1/2. Here we have to isolate y to get y by itself to find the slope. So I'll show you the work. Alright, so subtract 2x from both sides, 4y equals -2x plus 9. Get y by itself, divide everything by 4. We have this equation. So the slope of line 2 is -2/4, which reduces to -1/2. Notice the slopes are equal. So when the slopes are equal, your conclusion is line 1 is parallel to line 2. Again, in order to check the slope of a line given an equation, it must be in slope-intercept form. Slope-intercept form means y is isolated. Y is isolated. Alright, let's look at part B. Part B, y is by itself here, so the slope of line 2 is 1/3. We have to isolate y, subtract 3x, subtract 3x, y equals -3x plus 7. Y is by itself now. Therefore, the slope of line 1 is equal to -3. Well, look at this. Slope 1 is -3, slope 2 is +1/3. These slopes are opposite reciprocals, therefore line 1 is perpendicular to line 2. Alright, the last concept. In example 3 and 4, here are the directions. Write an equation for line 1, given the information. So, line 1 contains the point 5, -4, and is perpendicular to line 2, 5y minus x equals 10. In order to write a linear equation, you need a point and a slope. So far we have the point for line 1. We need the slope. Well, if we could find the slope for this line, what we can do is find the opposite reciprocal since they're perpendicular to each other. So let's start the work. Get y by itself, so I'm going to add x to both sides. 5y equals x plus 10. Again, we're isolating y. Y is equal to 1/5 x plus 2. The slope of line 2 is 1/5. If we already said line 1 is perpendicular to line 2, therefore the slope of line 1 has to be the opposite reciprocal. Opposite of a positive is a negative. The reciprocal of 1/5 is 5. So now let's use this information. The slope of line 1 is -5. We now have a point and a slope. Y equals, y minus y1 equals m times quantity x minus x1. We have our point. we have our slope. So we'll substitute all this information in. So that's minus a negative 4 the slope is negative 5, x is 15. Well, let's simplify this. Y plus 4 equals negative 5x plus 75. Let's get y by itself. Subtract 4, subtract 4. Y equals negative 5x plus 71. So here is line 1. Line 1 compared to line 2, when you put it in slope-intercept form, negative 5, 1/5. These two lines are perpendicular to each other. Again, the key is you need a point and a slope. The slope wasn't given, but they gave us that line 1 was perpendicular to line 2, so we found the slope of line 2, found the opposite reciprocal, and used it to find the equation of a line. All right, example 4. Line 1 contains point negative 2, 5 and is parallel to line 2, y equals negative x plus 4. Well, y is by itself already, so the slope is negative 1. Therefore, the slope of line 2 is negative 1 because when lines are parallel, slopes are equal. So we have our slope and point. Sorry, this should be M2, this should be M1. Okay, so now let's put it in point slope form. Y minus y1 equals m times x minus x1. Here is your x1, y1. Let's substitute everything. That's 5, that's negative 1, and that's negative 2. Use the formula. So y minus 5 equals negative 1 times x plus 2. Y minus 5 equals negative x plus 2. Get y by itself. We want this in slope-intercept form. Let's pause. Oh, negative 2. Sorry. So plus 5 plus 5. Y equals negative x plus 3. So this should be a minus because a negative times a positive is a negative. Okay, so here is line 1. And if we compare it to line 2, you'll notice that the slopes are the same, therefore they're parallel. So again, in order for us to find a linear equation, you need a point and a slope. Thank you.